Welcome to the Electrical and Electronic Engineering lecture series. Your anchor person is Professor Michael C. Ndinechi. Our topic is Communication Network Management, Part 2. We are going to continue with Part 1. We expected to have listened to Part 1 before this Part 2. Now, let us look at the International Standard Organization Network Management Model. The International Standard Organization, ISO, has done a lot in the area of communication network standardization. Their network management model is the primary means for understanding the major functions of network management systems. This model consists of 5 basic conceptual areas like performance management, configuration management, accounting management, fault management, and security management. Performance management, the goal of performance management is to measure and make available various aspects of network performance so that inter-network performances can be maintained at an acceptable level. Examples of performance variables that might be provided include network throughput, user response times, and line utilization. Performance management involves several steps which include to gather performance data on variables of interest to the network, analyze the data to determine normal or baseline levels, determine appropriate performance thresholds for each important variable such that exceeding of these thresholds indicates of network problem worthy of attention. Managed entities continually monitor performance variables. When a performance threshold is exceeded, an alert signal is generated and sent to the Network Management System, NMS. Each of the steps just described is part of the process to set up a reactive system. When performance becomes unacceptable by virtue of an exceeded user-defined threshold, the system reacts by sending a message. Performance management also permits proactive methods. For example, network simulation can be used to project how network growth will affect performance matrices. Such simulation can effectively alert administrators to impending problems so that countermeasures can be taken. Configuration management. The goal of the configuration management is to monitor network and system configuration information so that the effect on network operation of various versions of hardware and software elements can be tracked and managed. Because all hardware and software elements have operational quirks, flaws, or both that might affect network operation, such information is important to maintaining a smooth running network. Each network device has a variety of version information associated with it. For example, a typical workstation may have a configuration as follows: the type of version of operating system, the Ethernet interface version, TCP, IP software, the network software, the serial communication controller, the X25 version, SNMP software that is there. Configuration management subsystems store the information in a database for easy access. When a problem occurs, this database can be searched for clues that might help solve the problem. Accounting management. The goal of accounting management is to measure network utilization parameters so that individual or group uses of the network can be regulated appropriately. Such regulation maximizes the fairness of network access to all users. As the performance management, the first step towards appropriate accounting management is to measure utilization of all important network resources. Analysis of the result provides insights into current usage patterns. Usage quotas can be set at this point. Some correction will be required to reach optimal access practices. From that point on, ongoing measurement of resources use can yield billing information as well as information used to assess continued fair and optimal resources utilization. Fault management. The goal of fault management is to detect, notify users of, and to an extent, automatically fix network faults so as to keep the network running effectively, because faults can cause downtime or unacceptable network degradation. Fault management is perhaps the most widely implemented of the ISO network management elements. Fault management involves several steps like determining problem symptoms, isolate the problem, fixing the problem, testing and fixing all important subsystems, and recording the problem's detection and resolution. Security management. The goal of the security management is to control access to the network resources according to local guidelines so that the network cannot be sabotaged intentionally or unintentionally, and sensitive information cannot be accessed by those without appropriate authorization. Security management subsystems perform several functions such as identify sensitive network resources, including files, etc. Determining mailings between sensitive network resources and user sets, monitor access points to sensitive network resources, log out inappropriate access to sensitive network resources. Network management architecture and protocols. Most network management architectures use the same basic structure and set of relationships. End stations, otherwise known as managed devices, such as computer systems and other network devices, run software, allowing them to send alerts when they recognize problems. Problems are recognized when one or more user-determined thresholds are exceeded. Upon receiving these alerts, management entities are programmed to react by executing one, several, or all of the group of actions, including operator notification, event logging, system shutdown, automatic attempts at system repair. Management entities can also pull end stations to check the values of certain variables. Plotting can be automatic or user-initiated. Agents in the managed devices respond to these pulls. Agents are software models that compile information about the managed devices in which they reside. Management entities store this information in a management database within Network Management System, NMS, via a network management protocol. Well-known network management protocols include the Simple Network Management Protocol, SNMP, and Common Management Information Protocol, CMIP. Management protocols are entities that provide management information on behalf of the other entities. A typical network management architecture is shown in Fig 1. Simple Network Management Protocol is the most popular protocol for managing diverse commercial and research internetwork. It is a relatively simple protocol, yet its structure set is sufficiently powerful to handle the difficult problems presented by management of heterogeneous networks. SNMP is an application layer protocol designed to facilitate the exchange of management information between network devices. By using SNMP data, network administrators can more easily manage network performance, find and solve network problems. Simple management model, known as the SNP agent, are software models that run in the managed devices and make information available to network management systems via a network management protocol. If you look at Figure 2, you see the NMS sitting there and controls the agents. The agents are resident in the management database, and through the SNMP protocol, they send information to the user interface. So through proxies, the management database sends information and gets information from computers connected to them locally or through wireless. A managed device can be any type of node residing on the network, including communication servers, printers, routers, bridges, and hubs. Because some of these systems may have limited ability to run management software, they may have relatively slow CPUs or limited memory. Management software must assume the lowest common denominator. In other words, management software must be built in such a way to minimize its own performance impact on the managed devices. Because managed devices contain the lowest denominator of management software, the management burden falls on the NMS. Therefore, NMS are typically engineering workstation caliber computers that have fast CPUs, megapixel color display, substantial memory, and lot of storage space. One or more NMSs may exist on any managed network. NMSs run the network management applications that present management information to users. The user interface is typically based on a standardized graphical user interface, GUI. Communication between managed devices and NMS is governed by the Network Management Protocol. The Internet Standard Network Management Framework assumes a remote debugging paradigm where managed devices maintain values for a number of variables and report these on demand to NMS. For example, a managed device might keep track of all the following: number of certain kinds of error message received, number of bytes and packets in and out of the device, maximum output queue length for routers and other internet working devices, broadcast messages sent and received, network interfaces going down and coming up. Command type. If a NMS wishes to control a managed device, it can do so by sending a message required to the managed device to change the value of one of its variables. In general, managed devices respond to initiate 4 different types of command: the read command to monitor managed devices, and the write command to control managed devices. The traversal command are used to determine which values the managed device supports and to subsequently gather information in variable tables, such as an IP routing table. Traps. Managed devices use traps to synchronize reports and events to NMS. This is needed to rationalize incompatibility problems so as to allow communication between diverse systems. SNMP uses a subset of abstract syntax notation architecture. Network management centers and operations and management maintenance centers, OMC. A typical operations and support system, OSS, can be seen as a 2-level management function that provides centralized control of the network. The levels are Network Management Center, NMC, that concentrates on long-term system-wide issues, and Operation and Maintenance Center, which concentrates on short-term regional issues as depicted in Figure 3. See the first level, network management, the second level, network element management, and the network elements, which include the mobile services switching center, the authentication center, the base station controller, the base transceiver station. And you can see you can have more than one OMC, but one NMC. Thank you for listening. Please like, share, and subscribe. Drop your comments, questions, or topic you want me to lecture on in the comment section.